All right, good evening. Tonight we're going to be learning about how to take some words here and formulate an equation from the words. Then we're going to go to a graph. Then we're going to write the domain and the range. And then after that, we're going to write an equation from a graph that passes through a specific point. So let's get right to it. So up here, we're going to start with the absolute value function. Remember, absolute value function is always going to make a V. Might be opening up, might be opening down. Remember, it is symmetrical. It does have a similar point as a quadratic, a vertex point, if you want to call it that. And so we're going to be stretching the parent vertically by 3, so the y values are changing. It's going to be translate left 1 and down 4. So we have a horizontal translation and a vertical translation. So right here is our equation that I wrote. I went ahead and used function notation. Remember, g of x represents y. You don't have to use g of x. You could use h of x, f of x, p of x, whatever you want to label your transformed equation is fine with me. Okay, it's being multiplied by 3, so we have 3 as the a value, and it's translated left 1, so remember opposite, so x plus 1. So in this case, my h value is actually negative 1 because we're going to the left. I know it says plus 1, but remember it's always the opposite inside here. And then it's translated 4 units down. And these are the letters we use on our poster up in the front of the room for vertex form for quadratic function. So let's go ahead and graph this. So in order to graph this, okay, we're going to need some graph paper, an x and y axis. Here is our parent table. Remember that absolute value represents the distance a number is from 0. So notice that the distance -2 is from 0 is 2 units. The distance -1 is from 0 is 1 unit. So notice that these came out all to be positive, because they are distances from 0. And according to our equation, our horizontal change, the x values are all decreasing by 1. Remember, it's the opposite of what you think. So if it's plus 1, we're subtracting 1. So I went ahead and I subtracted 1 from all these x values. And that's how I got these numbers over here. I subtracted 1. Now for my y values, I'm going to take each of these y values and I'm going to multiply by 3, subtract 4. So times 3 minus 4. So 2 times 3 is 6, 6 minus 4 is 2. 1 times 3 is 3, minus 4 is -1. 0 times 3 is 0, minus 4 is -4. And it's symmetrical. Alright, so this is our transform table. So we can just plot these points. You're welcome to plot the parent if you like. -3, +2. -2, -1. -1, -4, and so on. Okay. Get my ruler out here. There's our transform graph. Now notice that our vertex point is translated from our parent, which goes through 0, 0. It's translated 1 unit left and 4 units down. Notice our A value of 3 can also be seen on the graph if you go over 1 unit and only 1 unit in either direction. Okay, this works for absolute value and quadratic. If you count up to the very first point, this represents your A value, which is 3. Now remember, if you count up, it's going to be positive A value. If your V is going down, your A value is going to be negative. Okay, let's talk about domain and range now, real quick, because we've already really learned about domain and range, but some of us still struggle. I'm going to go ahead and stick with the easy notation, interval. Remember, domain is left to right, so we have arrow to arrow. Nice, huh? That represents all real numbers. Range, lowest to highest. So remember, range is your y value. So our lowest y value here is -4. It's a closed dot, so we use a bracket. And it goes up to arrows, which is infinity. And that would be interval notation for the range. Okay, let's go ahead and move on to this next part. It says write the equation for the graph. Okay, let's take a look at this graph. So, first thing, you should do some observing, some critical thinking here and look at this graph. And you should notice, first of all, that the V, first of all, it's an absolute value function. Okay? It makes a V. So that's the first thing you should notice. So you should know that the parent of this graph is going to be y equals the absolute value of x. The second thing you should notice here is that it's opening down, which means our A value is going to be negative. So the other thing that you can get off of here is where the new vertex is located. So if you start at 0, you can see that it's been translated to the left 5 units, and it's been translated down 1 unit if you look here at the y-axis. So left 5, down 1. So just based on all of that information, we have a kind of a good idea on how to start writing this equation. So let's go ahead and go back to our paper real quick here. So remember that, left 5, down 1. Okay, we have some information here. It says that it passes through this point, -2, -7. So, and we know that the parent is going to be the absolute value of x. So the best thing to do here is fill in our information. So what do we know? And I'm going to put in the A, which represents your vertical stretch or compression. I'm going to fill in the H value, which we know it's going left 5 from the graph. And I'll fill in the K. Remember, the K is up and down, and it went down 1. Okay. So what information is missing? Well, we need a Y value and an X value, which is given to you right here. And we just need to calculate the A value. So let's plug this information in. So -7 goes in for Y. -2 goes in for X. And we're solving for A. So remember that absolute value represents a grouping symbol, so we're going to do what's inside here. So that's going to be the absolute value of 3. Okay, the absolute value of 3 is 3, because 3 is 3 units from 0, so we have 3A. And solving for A. So A is -2. So now we know what our A value is, which sometimes is the most difficult thing to get off of a graph. So our equation, I'm going to go ahead and call it y equals -2 x plus 5, absolute value of x plus 5 minus 1. And there is your equation. Let's go back to the graph. Now, we could have gotten the -2 off the graph. So notice we went 5 to the left, 1 unit down. Now, how could we get the -2 off the graph? Well, remember what I told you a little bit ago? You go over 1 unit, okay? Only 1 unit, okay? And it can be in either direction because this is symmetrical. So go over 1 unit, okay? And then if you count to the graph, 1 unit, 2 units. So I had to go down 2 units to get to the graph. And there's your A value. Now, sometimes it's not that easy to find the A value, and you'd have to go through these steps right here to calculate the A value. We would need to know at least one point, okay, to plug in for y and x, put in your h and your k, and then you would have the information in order to solve for A. Okay, I'll see you guys in class tomorrow.